Hi everyone. Today I will be using Malleable from distorted devices to make some music. Let's get started. I'm going to begin by creating a kick drum. I'll define a block named drum and give it an output for the audio, and I will set the audio to be a sine wave at 80 Hz. I'll use my drum definition to create an instance named kick, and I will send the output from kick to an oscilloscope. You won't be able to hear anything yet, but you'll be able to see it. Now, I'm going to set the volume of my sine wave using a gate. I'll add an input for the gate and a buffer for the volume, and I will set the volume using an attack decay envelope triggered by the gate with 50 milliseconds of attack and decay. I'll divide the output of that function by 100% to get a value between 0 and 1, and I will create an audio buffer which I will set the output from my wave function to. I will then set my output audio by multiplying the audio buffer by the volume. When I save my changes, the oscilloscope shows a value of 0, but I can trigger the kick one time by sending a value to the gate. What I would really like to do is trigger the kick using this MIDI controller. When I press this pad, you can see in the bottom left that it is sending a velocity for note C2. I can send this to the input gate using the vel C2 port. Before we listen to it, I'd like to make one more change. I would like the frequency of the drum to decrease after I trigger it. To do this, I'm going to add an input for the frequency, which I will give a default value of 80 to, but I'm going to add a buffer for the actual frequency, which I will give a minimum value of 10 to. I'll set the buffer frequency to the input frequency whenever the gate is non-zero, and I will set the buffer frequency to decrease by a small amount on each sample. I will then use the buffer frequency as an input to my wave function. So that we can test this, I'm going to temporarily disable the envelope. You can see a sine wave at 10 Hz on the oscilloscope, but when I press this pad, it will increase to 80 Hz. And when I let go, it will start to decrease. I would like it to start decreasing as soon as I press the pad and not wait for me to release that. To do that, I'm going to add another buffer called last gate, and I'm going to set that to the input gate as my last state. Then I will only set the buffer frequency to the input frequency if the input gate is high and it wasn't last time. If I save my changes, you can see this working. The frequency starts to decrease even before I release the pad. Let's have a listen. I'll reinstate my envelope and send the output from kick to the left and right audio ports. Great. Now, I'd like to add some controls for the frequency, attack time, and decay time. I'll add an input for the attack and decay. And I'll use these as parameters to my envelope. Then, I'm going to send a value from the UI1 input port to kick's input frequency, and I'm going to send a value from UI2 and 3 for the attack and decay time. I'll define these down here to be knobs with a minimum value of 10, a maximum value of 150, and the appropriate default. Now, if I save my changes, you'll see the user interface update, but I like to resize things slightly. Finally, if I turn this knob on my MIDI controller, you can see that it is sending a value for MIDI controller 3, this one 12, and this one 14. Let's test it. Great. Now that that's working, I would like to repurpose my drum module so that I can also use it for a snare. To do this, I'm going to add another input called input snare. And when this will be 0 by default, but when it's non-zero, I'm going to override the value set in this step with another value. What I will do is simply add some noise and divide the sum by 2. If I save my changes, the kick will sound the same, but if I send a value of 1 to kick's new input and press the pad, it will sound different. Great. I'm going to revert it back to 0 because this is for the kick, but now I'm going to create a new instance of drum called snare and set up its sends. Instead of vel C2, I'm going to use C#2, and I'm going to use user interface ports 4, 5, and 6 for my inputs and send a value of 1 to the imp snare input. And I'm going to use user interface 2 for the oscilloscope. For now, I'm not going to send the audio to where we can hear it. I'm going to follow MIDI controllers 9, 13, and 15, and I'm going to reposition the inputs on the row beneath the kick inputs, and reposition the oscilloscopes too. If I save my changes, everything will update and I can test it. Great. So that we can hear it, I'm going to create a mixer. I'll define a new block called mixer and give it 2 audio inputs and a single audio output. And I'm going to set the output audio to be the 2 audio inputs added together divided by the square root of 2. This should prevent any clipping. I'm going to use my mixer definition to create an instance named mixer, and I'm going to send the output from kick to mixer's input audio 1 and the output from snare to number 2. And then I'm going to send mixer's output to my left and right audio ports. Great. I'm also going to send the output from mixer to an oscilloscope. I'm not going to normalize it, but I'm going to give it a longer time period of half a second or 500 milliseconds so we can have a better idea of what's happening. Fantastic. Now that that's all set up, I would like to trigger the kick and the snare using a sequencer. So I'm going to define a new block called SEQ. The sequencer will need a clock, so I'm going to add a buffer for the clock. And I'm going to set the value of the clock using a wave function that will use the true on-loop wave type, for now with a frequency of 1 Hz. What that means is that once per second it will have a single sample with a value of 100%, but for the remainder of that second, every sample will have a value of 0. I'm going to add a step number, and I'm going to give it a minimum value of 1 and a maximum value of 9, which will allow me to create an 8-step sequencer. And I'll set the step number to increase by 1 whenever the clock is non-zero. And I will set the step number to revert to 1 whenever it's greater than or equal to 9. I'll add an output for our step number so that we can see it, and I'll set that to be the step number. Let's instantiate the sequencer, and I'll send its output step number to the user interface. And there it goes. I'd like to increase the frequency And to do that, I'm going to use the BPM to Hertz function, which will allow me to type in a tempo and it will generate the frequency for me. Let's increase that to 360 BPM. Great. So that we can use the sequencer, I'm now going to add a couple of output gates. Out gate 1 will be for the kick, and out gate 2 will be for the snare. I'm going to set out gate 1 to be 0, but when the clock is high, I'm going to tell it to use a value from this selection function, which will take the step number and choose one of these 8 values. I'm going to do the same thing with out gate 2. I'm going to trigger out gate 1 on step 1 and out gate 2 on step 5. And now I'm going to send those gates to the kick and snare inputs. And there it is. These sends have overridden these sends, so I will comment them out for clarity. Now that that's working, I'm just going to change the pattern slightly to make it more interesting. And now we'll make things a lot more interesting by using this sequencer to control some hardware oscillators in my Eurorack. I'm going to send a signal from this oscillator to this VCA, and I'm going to set the volume of this VCA using this attack, decay, sustain, release envelope triggered from the first output of my board brain Optex. That will have a value sent to it from Malleable. Let me get it connected. So this is going to work in more or less the same way as out gates 1 and 2. So I'll add an out gate number 3. But because I'm triggering the Eurorack module, I'm actually going to add a buffer gate 3 as well. Buff gate 3 is going to work in the same way as out gate 2 did, and out gate 1. And what it's going to do is set out gate 3 using an attack decay envelope. I'm going to give it 10 milliseconds of attack and decay, which should be enough to trigger my Eurorack module. Let me send it out to the first output on my board brain, which is going to be mapped to audio output 9 in Malleable. And let's set a pattern. Great. Now let's also set the pitch from Malleable. Let me get the 1 volt per octave input from my oscillator connected to the next output on my board brain Optex. In Malleable, to send a value of 0 volts, we send a 0. To send a value of 1 volt, we send 10%, 2 volts, 20%, etc. So what I'm going to do is add another output called out pitch 3, and I'm going to set that using a selection function, which will use the buff step to determine which of these values it selects. But I'm going to multiply the output of that selection function by 10%, which will allow me to type in something like 1 for 10% and 2 for 20%, etc. Let me send that to the output on my board brain, and it's going to go to audio output 10, but it's going to be the calibrated audio output 10 to ensure that the voltage is correct. Cool. I think it would sound more interesting if I put this oscillator through a filter. So I'm going to send it to a bandpass filter, and let's control the frequency of that bandpass filter using an LFO from Malleable. Let's define a new LFO, a new block called LFO, and I'll give it a single output called output. And for now, I'm going to set that using a sine wave at 1 Hz. I'll instantiate an instance of my LFO called LFO1, and I'll send its output to the next output on my board brain. Cool. Okay, let's use another oscillator. To do that, I'm going to replicate my gates and pitches in the sequencer for channel 3 for channel 4. And I'm going to send these values to the next outputs on my board brain. Let's get it connected. I'm going to use this output to set the level and this output to set the pitch. Because this oscillator works slightly differently, I can actually set the attack and decay times from Malleable. And I think this would sound more interesting if we adjusted the oscillator using another LFO. I'll instantiate another instance of my LFO called LFO2, and I'll send its output to the next output on my board brain. I would like to adjust the frequency of that second LFO, so I'm going to add an input to my LFO called frequency, which I'll give a default value of 1 to. And now I can just send a custom value to that frequency input for that LFO. Let's speed it up and see what it sounds like. Okay, a little bit crazy, but sounds good. Thank you for watching. I hope you like what you've seen. If you'd like to know more about Malleable, please visit the Distorted Devices website.